everyone. Today we are going to measure the MEBC versus magnetic field at low frequency. This is the setup for MEBC versus magnetic field. Here we put the sample. This is the sample holder with two Helmholtz coil, and this two wire goes to the locking amplifier here. In this locking amplifier, you can see the frequency, which is 100 Hz. We provide the 100 Hz frequency, and this is DC power supply. And you can see the function generator here. Here we provide 0.32 milliampere current, and this is the function generator. Here we give 100 Hz frequency. This is the whole setup for the MEBC versus magnetic field scan. We use the LabVIEW program to run this MEBC versus magnetic field. Here is the LabVIEW run. Currently we are running PGT nickel permeable sample where we put the sensitivity 100 millivolts per NA and current is 11.494. We provide the maximum current 15 and AC field 5 oysters. Current is step 0.1 and sample thickness is 0.3 millimeter because the PGT what we use have thickness 0.3 millimeter. That's why we provide thickness here 0.3 millimeter. This is the running MEBC versus magnetic field. We already have a data for this particular sample. I can show that data. We denoted MEVC, Magnetoelectric voltage coefficient, is alpha 31. This is the data that comes from that PGT nickel permeable sample. We plot this data in origin. This is the exact plot alpha 31 versus magnetic field for PGT nickel permeable sample. Here we can see the highest MEBC. You can see the highest MEBC. Which is 429.3093 millivolt per centimeter oyster at 48 oyster magnetic field. So this is the plot, final plot for magnetoelectric voltage coefficient versus magnetic field, a PGT nickel permeable sample. So at last I'm going to show the whole setup. This is the whole setup.